This is lesson 10.6, quadrilaterals. The general shape of a video game controller is shown. Describe the angles inside the four-sided figure. Well, just eyeballing them, it would appear that this angle is congruent to this angle, and that these two angles down here are also congruent to each other. Which sides of the figure appear to be parallel? Well, the top side here is obviously parallel to the bottom side. The left and right sides clearly not parallel. Which sides appear to be congruent? In that case, these two sides, the left and right side, would appear to be congruent, meaning they have the same length. A quadrilateral is a closed figure with four sides and four angles. Quadrilaterals are formed based on their sides and angles. The diagram shows how quadrilaterals are related. Notice how it goes from the most general to the most specific. This is what we call the quadrilateral hierarchy. Quadrilateral is a four-sided polygon, and we have trapezoids, which have one pair of parallel sides, parallelograms, which have two pair of parallel sides and opposite sides congruent. A rectangle then is described as a parallelogram with four right angles. A rhombus, again, described as a parallelogram with four congruent sides, and a square is a parallelogram with four right angles and four congruent sides. So it has all the characteristics of all the other parallelograms. It says the name that best describes a quadrilateral is the one that is most specific. So if a quadrilateral has all the properties of a parallelogram and a rhombus, then the best description of the quadrilateral is a rhombus. So you could say that a square is a rhombus with four right angles. If a quadrilateral has all the properties of a parallelogram, rhombus, rectangle, and square, then the best description of the quadrilateral is a square. So all squares are rectangles, not all rectangles are squares. All squares are rhombuses, not all rhombuses are squares. Draw a quadrilateral that satisfies each of the set of conditions. Then classify each quadrilateral with the name that best describes it. A parallelogram with four right angles and four congruent sides. So I draw my right angle, my congruent sides, draw a second right angle to the right here with a side that's congruent to the other two, connect the fourth side with a side that's congruent to the other three. I then have a parallelogram with four congruent sides and four right angles, which is defined more specifically as a square. A quadrilateral with opposite sides parallel. Draw two parallel sides of equal length, so the horizontals, parallel and congruent, the verticals, parallel and congruent. This then therefore is a parallelogram. Draw a quadrilateral that satisfies each set of conditions, then classify each quadrilateral with the name that best describes it. We're going to use our polygon tool here. A quadrilateral with exactly one pair of parallel sides. That would look something like this. You can see that the top and bottom sides are parallel. The left and right are not. We would classify this as a trapezoid. If you go back and look at the hierarchy, you can see that. Our second one says a parallelogram with four congruent sides. So we think that would look something like this. If I can do it successfully, that appears to be a rhombus, which is a parallelogram with four congruent sides, not necessarily four congruent angles or four right angles. The quadrilateral can be separated into two triangles, A and B. Since the sum of the angles of each triangle is 180 degrees, the sum of the angle measures of any quadrilateral is 2 times 180, or 360. So we can use that to find the missing measure in a quadrilateral. Find the value of x in the quadrilateral shown, so we know the sum is 360. We write x as our variable to represent the missing side. This is our equation. Down here, we combine all these like terms, get 217, undo the addition with subtraction, and find that our missing angle is an obtuse 143 degree angle. So let's do the same thing in our example here. We're going to write the equation first of all. 48 plus 157 plus 55 plus x equals 360. Combine our like terms, get 260 plus x equals 360. Undo the addition with subtraction. Subtract 260 from both sides. We find then that x equals 100 degrees. Classify each quadrilateral with the name that best describes it. In example number 1, we have 2 pair of opposite congruent sides and 4 right angles. That would make this a rectangle. In our second figure, we have no parallel sides at all. We have 1 right angle, which really doesn't affect our classification. This is a trapezoid. In our third example, we have 2 pair of opposite parallel congruent sides. This then is a parallelogram. In the figure, the photo shows a sailboat called a schooner. What type of quadrilateral does the indicated sail best represent? Kind of hard to see here. Looks like this. Again, 1 pair of parallel sides makes this a trapezoid. Trapezoids have 1 pair of parallel sides, which means we have to go back and change this definition. This is simply a quadrilateral. No parallel sides means not a trapezoid. Number 5, in quadrilateral DEFG, D is 57, E is 78, G is 105. Missing angle F we're going to represent with X. 360 is our sum. We combine those like terms, we get 240 plus X equals 360. Subtract 240 from both sides. X equals 120 degrees. Let's see if we can throw number 6 on here as well. We have 146 plus 55 plus 59 plus X equals 360. We combine all those like terms again and we get 260 just like we did in one of our earlier examples. We undo the addition with subtraction. We subtract 260 from both sides. X then equals 100 degrees. Our last 2 examples, number 7, same process. 108 plus 73 plus 115 plus X equals 360. Combine those like terms, we get 269 plus X equals 360. Subtract 269 from both sides to undo that addition. Isolate the variable. We get then X equals 64 degrees. Somehow that doesn't look right to me. I might have to go back and look at that. Number 8, 71 plus 164 plus 90 plus X equals 360. Combine like terms, 325 plus X equals 360. Undo the subtraction or the addition with subtraction. Subtract 325 from both sides. X equals 35. Let's go back and check this one. 269 minus, or 360 minus 269. This is 20 or 35. We get a 1 here. We borrow here. We've got 15. It appears to be 91 degrees, not 64 degrees. I don't know where that came from. Here's our vocabulary for this lesson: quadrilateral, parallelogram, trapezoid, and rhombus. Please make sure those are in your notable. I draw a picture of each of them to help me remember which is which. The hierarchy is a good idea to draw that. At this point, you should quit the video, go to Naiku, take lesson quiz.